Hello, my name is Tom Krause from igus, and I welcome you today to the webinar about 3D print gears. So as you probably know, until a few years ago it was really hard to get your special gear, for example by machining or by injection molding. You need to have the tool, which is really expensive and needs lots of time. And yeah, if you want to change the shape, you need to have a new tool, and it's really complicated. But now we can 3D print any gear we want, and that's the topic today. I welcome you, and yeah, let's start. So the most important thing at first, you can always or you can get also such a sample box and such a flyer where you also find lots of this informations where we speak today about. Just write us a short email which will be shown below, and then you can get a small box with some printed gears and a flyer with lots of information about it. Okay, so yeah, what's the most often question we get about 3D printing or about 3D printing the gears? The most often question is that or that gear printable? And yeah, this is a really easy answer to answer, because we can print any gear with the wall thickness above 0.5 millimeters. Because yeah, the laser spot is about 0.5 millimeters, and that's why we cannot do any wall thicknesses below this wall thickness. But besides of this point, we can print really any gear with any shape we want to have. And there's also a second yeah, let's say the rule. That's the size of the printer. So the printer has, we do it by laser sintering, has a size of 170 by 220 by 300 millimeter. So any part that fits in this size, we can print in one piece. And if we have a gear or any other part that's bigger, then we just separate it and then we print it in different jobs, and then we just put it again, and that's how we can do also bigger gears. So this is really the most often question, and this is the big advantage in printing. We really can print any gear or wear part that you want to have, and that we can do in 1 to 3 days. So what's the difference between printing and machining? For example, so at machining, you have some kind of bar stock or plate where you remove the material that shouldn't be a part of the gear. So, for example, if you do a lightweight design, then in this, like this gear, then you would need to remove more material. So you would have a longer machining time, and that's why at lightweight designs, the machining part is more expensive because you have just a longer machining time. But at 3D printing is totally different. We add material in each layer so that a part is cheaper when I have a lightweight design, because I need to add less material. And that's another great advantage of 3D printing, that we can do any shape, of course, and also lightweight design with a big advantage in costs. So I brought you one example of a big gear where we have a comparison of the weights, which you see here. And yeah, this is a really big gear. It's like, yeah, it's a really big one. And in this case, we reduce the weight in this case, put some holes inside, and in this case we reduced the weight by nearly 50% in this case. This has also the advantage that I need to have, for example, a motor with lesser forces, because it's just a reduced weight in this case. But the other advantage is yeah, less material, and that's why it's also cheaper in this case. It's about 12% in this case, because I have a reduced printing time. So this is another big advantage of printing the gears, that we have advantage when we are doing lightweight design. But what else? What other advantages do we have when we are 3D printing gears? So yeah, I brought you another example which you see here. So let's say, for example, I have a one gear drive. Yeah, one gear is a gear like this one, where the shaft rotates and then the wheel rotates in this direction. And usually, if you want to do such a one gear and you want to machine it or you want to injection mold it, then you usually do a simplified design, which you see in the picture on the top. So a simplified design is necessary in order to make it producible at all by machining or injection molding, or to make the tool less expensive. And this causes at the end that I have a really small contact area between the one shaft and the one wheel. And the small contact area leads to a high pressure, to a high surface pressure, which at the end causes a quicker failure of the gear, because you have at the higher pressure a higher wear rate. But at 3D printing, I don't care if it's a really complex gear shape or teeth shape, or if it's a really easy shape. So yeah, if you can see the picture again with the differences, and yeah, in the picture, in the second picture, you see the shape is much more better. It is really the perfect shape in order to have a big contact area between the one shaft and the one wheel. The big contact area leads to a reduced pressure, and the reduced pressure leads to a higher lifetime. And yeah, and that without any additional cost, because at the end it has the same size, and for us it's only important how many pieces fit in the print room. That's the main cost driver, and therefore I can easily increase the lifetime by doing a optimized teeth shape in this case. And yeah, that's another big advantage of printing gears. And you can even use this for developing, because on every day you can choose another teeth shape or gear shape, because we are not bound to any tools. And that's how you can do lots of different tests very quick in order to find your best shape and the best performance of your special gear. But as you probably know, at igus is always about the materials. We are developing materials which are self-lubricating. That's the same for the gears. And yeah, I can show you in the next chart some wear results which we've done, because the white material here, the igus i6, is especially developed for these one gear applications. Yeah, and if I do a test in this case with a one gear which has 12 cycles per minute and 5 Newton meters, it was a gear of this size roughly. And if I compare it with the regular machined gears, then a PPT gear in this case failed already after 200,000 cycles. The PUM, which is a standard material for gears, also machined in this case, failed after 600,000 cycles. And the igus i6, which is especially developed for one gear drives, didn't fail at all. We had to stop the test after 1 million cycles, because it's already 2 months of testing time. And yeah, there wouldn't be really a failure. And that's the second advantage for the one gears. So the first one, as I said, is the shape. You improve the shape. In this case, you have a material which is especially made for one gears. And that's how we have also the better lifetime. Of course, in this test, all gears had the same teeth shape in order to do a proper comparison of the materials. If you now improve the shape even better, then have an even higher lifetime. Okay, so I hold it down. igus i6, the white material we especially take for the one gear drives. But as you know, there are also lots of other gear types, like gears like this type, or even the regular gears, like these regular gears, for example. And for these regular gears, you rather take igus i3, because and that's what we want to show you in the next test result. That we have with igus i3 a much higher lifetime for these regular gears. And yeah, it was such a gear in the test, about 30 teeth, modulus 1. And yeah, if you can, it was about the size, and we had about 2 Newton meters of loads, and we compared again with POM, because POM is a standard material, and we saw that with the igus i3, we have a similar lifetime than a POM machined gear. But as you know, we can change the teeth shape really easily. And yeah, what did we do? We just changed the radius of the teeth foot and increased in this way the lifetime even more, so by 50% even more, as you just have seen. And yeah, that's a thing we can easily do in order to increase the lifetime even further. And yeah, that's how you choose different materials for these kinds of applications. And yeah, in the next slide, we summed up for what kind of gears we choose which material. So at the end, it's really easy. You use iGlide i6, this is the white material you use for the worn gear drives, and for all other gears, you choose iGlide i3. It's really that simple. But yeah, what's the reason why you have these different materials for different gears? So as I said, iGlide i6 is especially for the worn gears and has a little bit reduced strength compared to iGlide i3, but it has a higher elongation at break, so it's more ductile. That's why you also choose this material, for example, for snap fit parts. And for all other parts, like all gears or bearings, you use the iGlide i3. So yeah, so these are the recommendations for the SLS materials. But yeah, as you know, we need to have a 3D model, and it's really important for us to have a good 3D model, because at printing it's the only manufacturing method where you directly use the 3D model for production. So normally, if you machine a gear, you just grab the right tool to machine it. But we load the model directly into the printer, and that's why it's very important to have a good model. And in the next slide, we show you a comparison. You see a simplified gear design, which causes a reduced lifetime or more noises. And on the other side, you see a good gear quality in order to reach the best lifetime and low noises. So how can you get such a perfect gear shape? If you have a CAD program, sometimes they have tools inside which you can use for it, but you can also use the gear configurator from igus, which we're going to show you now. You can go, for example, to igus.eu, for example, or UK or whatever, and then you go to the configurators, of printing, and then to the gear configurator. So the gear configurator is an online tool where you can configure the 3D model of your special gear. So far for the standard gears, and you see that we have here the perfect shape of the teeth, so that we can use this 3D model directly for production, and that we have here the highest lifetime. We also included already the results from the test that we have a higher lifetime only because of a optimized teeth design. Yeah, if we scroll down, then you see the different options we have, the different options how to make sure that the torque from the shaft is transmitted through the gear. And a little bit more below, you can put in the different values like modulus. Modulus is the size of, or a value for the size of the teeth. Here we can take, for example, 1 millimeter in this case, then the number of teeth. Let's say we have 18 teeth in this case, and a width of 10 millimeter. Of course, you can put in lots more different data here. You can also configure like double gears, for example, which you can also configure here. And yeah, if you have the model you want to have, you can also look at the 3D model, and then you just download the 3D model in a step format, yeah. And yeah, then you just download it on your computer. so that you can put it in your CAD program to make it fit with the other parts, and you can directly use this to download it, to calculate the price online. Yeah, you just hit the download button, and then you need to go to the 3D printing service where we can directly calculate the prices online. So for example, igus.eu and then /gears, and then you can get directly to this tool, and yeah, you'll just hit igus.eu, and then you go to the printing service. Yeah, there is it. And then here you can upload the model you just configured. Of course, you can upload here any other part also, like bearings, lead screw nuts. So we're not only making gears, we're making all kinds of special wear parts, always with our own plastics where solid lubricants are inside, which is also suited for gears. Yeah, and here you see directly the price. In this case, it is a special gear. The price depends on the quality of the quantity and of the size. In this case, 14 euros. So I promise you, for this price, you don't get the machined gearing for this price, because especially at lot size 1, it's much more expensive by machining. Yeah, as I said, the price depends also on the quantity. Now we can put in like 10 pieces, for example, and then you see the price gets reduced depending on the part quantity. In this case, it's about 4 euros in this case. And then you can decide in the next point by add to the shopping cart that you want to order it directly. And then you have a shipping time about 3 days in Germany, and then other times depending on the different countries. Or you can also request a quotation. Then you get usually a quotation which you can also use to order your special gear. Okay, so now we showed you the different materials. We showed you how to get the model, how to get the price, but what's most important, what's the lifetime of the special gear we just configured. And that's really new. We have it about 4 weeks. You can also now calculate the lifetime. We go just to configurators, again to bar stocks and printing, and there you have the year lifetime calculator. So it's probably the only lifetime calculator for 3D printed gears at all. And yeah, as you know, we use iGlide i3 in this case, and here you just put in the data of the both gears, because you always calculate 2 gears in the same time. So let's say we have about 18 teeth at the smaller gear. We have a gear width of 10 millimeters, a modulus of 1. 1, as I said, modulus is a common value for the teeth size. The bigger gear, let's say, has 50 teeth and also a width of 10 millimeters. So this is the size of both gears. And then you can put in the speed and torque of one of both gears. So let's say of the small gear, 100 cycles per minute or revolutions per minute, and a torque of 2 Newton meters, for example. Yeah, then you can also put in some other data, and then you go just to calculate. And yeah, now you have the lifetime of the small gear has in this case 21 hours, so it's not that much. And of the big gear has in this case 2,500 hours. So now we can check how can we increase the lifetime. So let's change the width of both gears, for example, to 12 millimeters. Because yeah, you need to have, let's say, more plastic in order to have more reduced tenses in the part. And by increasing the width or the modulus, we have more plastic, and then you can do higher loads. Okay, then let's calculate again. And now we have 235 hours. And yeah, we could now also increase the modulus or increase even more. But there are, of course, also, it's similar to bearing applications. If you have a more easy bearing application, you can do both parts out of plastic, so the shaft and the bearing. if you have a more challenging bearing application with high speed, then one part, so then the shaft needs to be out of metal, and that's similar for gears. If you have a gear application with really high torques or high speeds, you can increase the width, of course, or the modulus. And if this is not helping, then you can choose the smaller gear out of metal. That's what we can do now. So change please the smaller gear to metal in this case, which we do not, by the way, we only do plastics. And then then you can, as you see, increase the lifetime also of the other gear because the heat gets faster away from the application. Yeah, so this tool you can use in order to improve the lifetime of your gears, because you can check different gear values, and you can of course check if the application is doable at all. Yeah, so this is a great tool. You can just try it in order to test your special application. Okay, so now we know also, at least of the simple gears, the lifetime. But what's also a really common question is when is 3D printing or 3D printed gears cost-wise more efficient than other manufacturing methods? Because that's at the end the most important point at all. And we have the printing size, as I said, about 170, 220 by 300 millimeters. And this size, or this printing room, always needs to make a certain number of cells. So if I have a really tiny part, like a tiny gear, then they are fitting several thousands of parts inside, and I get a part price below €1. But if I have a really big gear, like this one, for example, then they're fitting only, I don't know, 100 or 150 gears inside, and this one is of course then more expensive. And then it depends on the quantity. If I have only one piece, then maybe it's also for the big parts more suited, but if I have bigger quantities, then printing is, especially at the smaller gears, efficient, so that we also do serious applications about 10,000 pieces, for example, by 3D printing or by laser sintering, because it's more cost-wise interesting than the other manufacturing method. And this can be, for example, a gear like this one. So this is a gear, it's a double gear, and usually you cannot machine such a gear. You can machine, of course, 2 single gears and then put them together somehow, glue them together, but it's not a quite good solution. But in such cases, we can also have a big price advantage, or for example, if I have an inner square, which makes the machining more complex or more cost-wise, it's a higher cost, then we have also a big advantage in the price. At the end, we printed last year about 100,000 parts we sold to customer, and it can be a single part, or it can be also serious applications for up to 10,000 pieces. Okay, so this is all information about the gears, which I just told you, and now we have time for the questions, which just coming in. We have the different sources, as I said. So we get the question, for example, how can be the gear, or can I use gears inside, or the printed gears inside of cars? So yes, you can use it inside of cars. It depends on the point where it's used. So inside of the motor or close to the motor, it's really hot. It can be around 100 degrees. This is too hot for these printed gears, because the upper application temperature of these materials is about 80-90 degrees. So you couldn't use it inside of the motor. But there are lots of other applications in the car, like different lights that are set up, or other adjustments where you don't have these high temperatures. And then, of course, you can also use the printed gears. Okay, other question is, what's the precision of the printed part? That's also a really good question. So usually at laser sintering we have a precision of plus minus 0.1 millimeter. Depends also a bit on the size. So yeah, there are really lots of applications where we have gears where this precision is really good enough and where we can use them directly without any rework. Okay, so if I'm right, then we don't have any other questions, and then yeah, thanks for your attention. Don't hesitate to write us your questions afterward or to contact us to get your sample box or the sheet with some informations about the printed gears, or we have also really new design guide in order to give more tips about the printing, but as I said, at the end we can reprint any part. So yeah, thanks for your attention. I just see we just got a question, what's the maximum tension the tooth can support? So the tension depends on the temperature on the teeth, and it depends on the required lifetime, of course, yeah. So at the end, you can just put in these data in the lifetime calculator, and that's how you can check your application. Yeah, so it's not a single value, it's a matrix of values depending on temperature and lifetime, so I cannot give you a short answer, yeah. Okay, then thanks for your attention. Yeah, don't hesitate to write us your mails afterwards, your questions, and also to get your printed gearing sample and also some information about the printed gears. Okay, thanks.